Right then, in this video we're going to talk about the next bit of the exploration section. We need a highly appropriate methodology. How do we show that we've got a highly appropriate methodology? First thing we do is we need an apparatus list, which is nice and specific. So you'll notice that I've been very specific about the size of the masses I'm going to be using. So the experiment was to measure the spring constant of the spring, which is attached to the back of this cart, by compressing the cart by a certain distance and then allowing it to propel itself through a light gate. So the next thing we need is a 2D apparatus diagram shown set up ready to take measurements. And then a method, step by step, in the imperative, like you're giving instructions in a recipe. And you tell me which values of the independent variable you're going to be using. The next step, and it crosses over with this one, consideration of the factors that might influence the relevance, reliability and sufficiency of the collected data. So that comes in here. So now we need a list of the variables. So the independent variable is the mass of the cart. And you tell me how you measure this. So we're measuring using a top pan balance. You tell me that is the device we need to measure this thing. You tell me how I might avoid errors in the measurement of this thing. So systematic errors, we can do that by whatever method, and we can take repeat readings to reduce the effect of random errors. And now we need to explain why we've chosen the range that we've chosen. So the minimum mass is chosen because, in this case, because that's the minimal mass of the trolley plus the interrupt card, and the maximum usable mass is this, because at any more than that the friction will start to come into play. So for an example where we might be dropping a ball over a certain distance onto a trapdoor switch, perhaps if the height is too small, it doesn't have enough momentum to close the trapdoor switch, and if the drop height is too high, it might be hitting terminal velocity. So you're not measuring the acceleration that you think you're measuring. So yes, what we do is we explain the range we're using, the maximum, the minimum. Now, what we need to do is we need to give the resolution of the measuring device, which in this case is plus or minus a gram. Now, if we're measuring things from a mass of half a kilogram up to 4.5 kilograms, this is a really small percentage error, and that's what you want. This is all part of the sufficiency of the method, whether you're taking data with a small percentage error. The dependent variable. Now we do exactly the same thing as we did for this, but with the dependent variable. You tell me what it is you're going to be measuring, you tell me how you're going to measure that, and how you reduce any errors. So the nice thing about, in this case, a data logger is it reduces the uncertainty due to human reaction time. In fact, it removes it. You tell me about the resolution and the time measurement. And again, 0.001 seconds is probably going to be less than the time taken, much less than the time taken for the cart to go through the light gate, so we expect this to be a tiny fraction of the error. And then we've reduced random error by taking multiple readings. Now the next bit, so that's all about the appropriateness of the methodology, and we've started to talk about this relevance, reliability and sufficiency of the collected data. The next thing that influences the reliability are the control variables. So you need to tell me what all the control variables are in this case. This experiment has a lot of them. There's a length of the interrupt card, the compression of the spring, the distance from the starting position of the car and the light gates, the surface the car is running on, and anything that has a number, you tell me what number that is. So the length of the interrupt card was 10.0 centimeters, and because we measured it on both ends of a 30 centimeter ruler, the uncertainty in the length measurement is plus or minus a millimeter. And again, 1 millimeter in 10 centimeters is a small percentage uncertainty, so this is a good way of measuring the length. Same thing for compression of the spring. You tell me the number, you tell me the resolution, and therefore that's a good way of measuring that thing because the percentage uncertainty is small. And these other things will also affect the results, and you can tell me why they have to be a control variable. And finally, evidence of the significant safety, ethical, environmental issues that are relevant to the methodology of the investigation. This is usually, for physics, not applicable. If there are no relevant safety concerns, as there aren't in this experiment, you have to say there are no relevant safety concerns for this experiment. If you don't, then you get 0 for this mark here, standard not reached. If there are no significant safety concerns and you say that, then we're gravy. You do have to specify if there are any safety concerns, of course. There might be if you're boiling water or you're dealing with high voltages. And that is the exploration section.